All right, here is problem number 2. The cost for a crew to come and landscape your yard is $200 per hour. The crew charges an initial fee of $100 for equipment. All right, complete the table and the graph below to show how much it will cost for the crew to work on your yard for 6 hours. Okay, so it's $200 per hour and $100 for the equipment. $200 per hour, just so that we can see those really clearly. All right. Let's go green. I feel I'm in a green mood. Okay, cool. So the charge is $100 for equipment. So it's going to start before they even do any work. It's $100 for the equipment. Okay, it's $200 per hour. They're going to go 2 hours. So if it's $200 per hour, we're going to go up 400. So this will be $500. It's $400 for working for 2 hours plus the $100. I'll write this down. So it's $400 for working the 2 hours plus the $100 for equipment is going to give us $500. This is the 2 times 200. And this is that equipment fee. Okay. And then for 4 hours, we're going to go up by 2 more hours. So we're going to go up by $400 again. So it's going to be $900, which again is, that's 6 times 200. Nope. It's 4 times 200 because it's 4 hours times $200 per hour, which is $800. And then plus that extra 100 for the starting amount. And then we're going to go up another 400 because that's going up by 2 again. 9 and 4 is 13, so $1,300. Okay. So the graph 0, 2, 4, 6. Probably the same scale as last time is going to work for us. The time in hours. This is the x. That's the y. That's the x-axis. That's the y-axis. It's always like that. And it's because the x is the independent or the input variable. Input variable always goes on the x-axis, the horizontal axis. That's just how we do. Okay, so then this is time in hours. Time in hours. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This might be a 10 by 10. 1, 2, 3, 4. Oops, stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Nope, it still goes up by 15. That's perfect. Okay, so we're going to do $100, a scale of $100 for the Y. So this is the amount or the cost in dollars. And I'm not going to label every one because it's going to get to be too much. So 1, 2, 3, 4, $500. 1, 2, 3, 4. Oops. 1, 2, 3, 4. $1,000. 2, 3, 4. $1,500. Okay. For this situation, we have a starting value of $100. So that means on this x, when x is 0, y is already at $100. And then it goes up by $400 every 2 hours. 1, 2, 3, $400 every 2 hours. $400 every 2 hours. Okay. If you wanted to, okay, so the rate of change goes up $400 every 2 hours. If you wanted to, you could divide that down to be $200 per 1 hour. which makes sense because that's what they told us in the problem, $200 per hour. This is your rate of change. This one was your starting value. All right. So if I wanted to do $200 every 1 hour, that would put in these points here, which you can see are still on that same line. And I'm going to go ahead and draw my line freehand, I think. Your line should go more or less like that. All right, an equation for the cost of landscaping for H hours. You can use C and H if you want to. The cost of landscaping, this is the output, this is the Y. And the time, this was the input, this was the X. So Y equals 200X plus 100. So this equation makes sense because 200 times the number of hours and then plus that $100 fee. Is the context linear? Yes. It is linear. The graph is a straight line. The rate of change is a constant amount. It's adding the same amount every time. It is linear. Compare this landscaping problem with Hillary's savings. How are the problems similar? How are they different? They're similar because they're both adding 200 every time. And then how are they different? There's two things that are different. Let's see. Yeah. There's two things that are different. So first of all, the landscaping, this problem has starting value of $100. So all of the points in the table are $100 more than what Hillary's was. The other thing that's different is that this table, if you like, the table is not going up by 1 hour, it's going up by 2 hours, which is why we're adding 400 instead of adding 200. And if you look at Hillary's is going up by ones, which is why we're adding 200 every time. But if I wanted to skip to go from 4 weeks to 6 weeks, from 800 to 200, that is adding 400. I don't really have space for that, but that's okay. So it is the same rate of change. It's just because the weeks for the landscaping problem is going up by 2. The corresponding Y value is going up by double the rate of change because the time and hours is going up by 2 every time. How would you change the context of savings so it could be modeled by the same equation as the landscaping context? If she started with $100, like you'd need to somehow get that $100. So if she started with $100 already in her bank account, then the situations would be the same. How would you change the landscaping context so it could be modeled by the same equation as the savings context? Take away that starting value if they did not have the $100 initial fee for equipment. Okay. I hope that was helpful. I'll see you soon. Bye-bye.